the quadratic formula using the discriminant. As we know, when I'm solving a quadratic equation such as these, I can have two solutions, I can have one solution, and often I can have a situation where I can't solve it at all. There's no solutions. And we've mentioned it before, but we keep saying we'll keep coming back to this. We're now back to it. It is useful to remember that any quadratic equation graphs a parabola. So if I said that y is described by this rule, then what I'd expect to get is a parabola, and the solutions to the quadratic equation are the points where the equation, which I'm allowing to be y to graph it, equals 0. So when y equals 0, we have the x-intercepts, and where this parabola cuts the x-axis, you can see there's two possible points. So this quadratic equation that graphs this parabola has two possible solutions. We'll learn more about graphing parabolas later too. If my parabola was sitting right here, then there's only one point where it crosses the x-axis or touches the x-axis. So there's only one point where the function equals 0, and so this has one solution. And if my parabola was sitting completely above the x-axis altogether, then there's nowhere where it cuts the x-axis, there's nowhere where it equates to 0, and so it has no real solutions. We cannot solve it using real numbers. And again, there'll be a video which I'll link you to, which will explain that concept of real numbers in more detail, and is really quite fascinating. Now, if we go back to our quadratic formula, it's very obvious to us that it's this square root part, plus or minus this square root of this expression, that often gives us two solutions, because I've got to do plus or minus this expression. So if I got like b squared minus 4ac was 4, so I've got the square root of 4, which is 2. I've got to do plus 2 and I've got to do minus 2, so I get two possible answers. If this number in here turned out to be negative, then they're asking me for the square root of a negative number, and I can't have that. It doesn't exist. It's not a real number. I couldn't solve this when I'm asked for the square root of a negative number. So if this expression under here is negative, I can't solve it. And the other option that we've got, so I've had positive, two solutions because I've got to add or subtract a number. Negative, no solutions because I can't do the square root of a negative. Excuse me. Excuse me. My only other possibility here is that, well, what if b squared minus 4ac is 0? The square root of 0 is 0. Plus or minus 0 doesn't change anything. So there's only one solution if this number under the square root is 0. And that expression under the square root in our quadratic formula is the discriminant. It lets us find out, or discriminates between, expressions or equations with one solution, two solutions, or no solutions. So this is the discriminant. Its symbol is that little triangle, which is delta, b squared minus 4ac. That's the discriminant. And if the discriminant is less than 0, there's no real solutions. And in a test, you'd say there's no solutions. If the discriminant equals 0, there's one real solution. And it's worth noting that if this equals 0, then all of that cancels out, and our solution for x is just negative b over 2a. So you've got one solution when the discriminant is 0, and it's nice and quick to get it because you don't need to do the whole quadratic formula because this comes out to 0. And if the discriminant is more than 0, that is, it's positive, there are two real solutions, and you would solve using the quadratic formula. To find those two solutions. So this is useful partly to find out, can I solve this before I start doing the whole quadratic formula, and partly just to answer the questions where we use the discriminant. So these sort of questions: determine the number of solutions to the following quadratic equations using this discriminant. Now, I'm going to do full working where I write a equals 1, b equals 5, c equals negative 3. It's a really good idea to do that. You write the formula for the discriminant, b squared minus 4ac. You substitute in your values. 5 squared minus 4 times 1 times negative 3. If you prefer, because multiplying with negatives does get a bit messy, you'll notice in the textbook they do set it out as just brackets. 5 squared minus 4 times 1 times negative 3. That's a perfectly acceptable option for setting it out without the multiplication signs. You might also want to put any negatives in brackets if you're doing it this way. It is a little bit up to you. I usually pop b into a bracket because if you've got a negative b, you really want to remember that you're going to get a positive answer. Anyway, it's 25, negative 4 times negative 3 is plus 12. So my discriminant is 37, and the only thing I care about is it positive, negative, or 0? It's positive. My discriminant is greater than 0, therefore there's two real solutions. So if you were asked to use the discriminant to determine the number of solutions, that is your appropriate working, and it's a really good idea to write this down as well. Another example, state our values of A, B, and C. Be aware that you've got a negative b, and that's likely to trip you up. The discriminant is b squared minus 4ac. Substitute in your values. Negative 3 squared is 9. 4 times 2 is 8 times 4 is 32. 9 minus 32 equals negative 23. So my discriminant is negative. I don't care what the number is in these examples. I just care positive, negative, or 0. My discriminant is negative, so it is less than 0. Therefore, there are no real solutions. If you did this with the discriminant for this equation and were asked to solve it, there'd be no point putting this into the quadratic formula because there aren't any solutions. Last one. Now, if you're feeling very clever, you'll recognize that this is a perfect square. And perfect squares only have one solution, because if I factorized this, I'd get x plus 3 squared. My only option is that x plus 3 equals 0, so x is negative 3. So when you see a perfect square, you should be pretty sure already there's only going to be one solution. But let's work this out. Identify A, B, and C. Discriminant. Substitute your values. So 36 minus 4 times 9 is 36 equals 0, which is not a big surprise. The discriminant equals 0, therefore one real solution. Now you can see that we really don't need the quadratic formula in that case. Now I didn't ask you to find the solutions in this one, but it's worth noting that you'll remember when there's only one solution, I gave you the little shortcut for finding out what that solution is. So negative b, negative 6 over 2, x is negative 3. There we go. We worked out that that was going to be the case because this is a perfect square, x plus 3, x plus 3. The only solution is x is negative 3. But that's another way of getting the solution when there's only one real solution. So that's the discriminant. You need to be able to use it to work out how many solutions there are, and also therefore use it to work out if it's worthwhile trying to solve a quadratic equation.